topic is about describing the horizontal and vertical motions of a projectile. When a ball is tossed upward, it will not continue moving straight up to the sky, same with a ball hit by a bat. Instead, it will fall back to the ground following a parabolic path due to the action of gravity. This motion is called projectile motion. Projectile motion is the motion of an object launched or thrown horizontally, or at any angle other than 90 with respect to the horizontal, following a parabolic path called trajectory. Projectile motion is a combination of horizontal and vertical motions, in which each motion is completely independent of each other. The horizontal motion is a uniform motion, while the vertical motion is a free fall. Like a rolling ball on a frictionless floor, an object thrown or launched will keep moving forward at an equal distance each time interval, because there are no horizontal forces acting on the object, and it is neither affected by gravitational force. In this case, the velocity in the horizontal component is constant, which means that the object is not accelerating. On the other hand, vertical motion is affected by gravitational force. The vertical velocity of a projectile, either downward or upward, changes by equal amounts during an equal time interval, which means that there is a vertical acceleration. To understand this clearly, consider this example. Angelo used his knee to toss a soccer ball at an angle theta with an initial velocity of v naught. The soccer ball followed the trajectory shown in the figure. Let us analyze the horizontal and vertical motions of the ball denoted by x and y, respectively. We can see that the horizontal velocity of the ball at any time t is the same as the initial horizontal velocity. It means that the horizontal speed and the direction never changes, just as shown in the figure, hence the horizontal acceleration is zero. On the other hand, vertical velocity decreases at constant rate during equal time intervals until it becomes zero at the maximum height. After reaching the maximum height, the vertical velocity will increase again at the same rate. Moreover, there is a vertical acceleration because the velocity changes both in speed and direction. The vertical acceleration negative 9.8 meter per second squared is constant all throughout. Now let's try to put some numbers. If the angle of projection is 30 degrees, and the initial velocity is 5.88 meter per second, what will be the values of initial horizontal and vertical velocities? How about the velocities after 0.1 second? After 0.2 second? We have discussed previously that the horizontal velocity is constant all throughout, hence the horizontal velocity is same as the initial horizontal velocity, which is 5.09 meter per second. Now, let us compute the vertical velocities at time 0.1 second and 0.2 second using the equation for vertical velocity. The vertical velocities after 0.1 second and 0.2 second are 1.96 meter per second and 0.98 meter per second respectively. The velocities we calculated are recorded on the table. Now it is time for you to try. Compute the horizontal and vertical velocities for each given time. Did you get the same answer? Good. Now, let's look on the velocities. We can see that the horizontal velocity is constant all throughout, while the vertical velocity changes in speed and in direction. The change in direction is indicated by the sign. Positive sign indicates that the ball is moving upward, while negative sign indicates that the ball is moving downward. In summary, we have learned that projectile motion is a combination of horizontal and vertical motions. Horizontal motion is a uniform motion, which means it has a constant velocity and is not accelerating. On the other hand, vertical motion is a free fall and accelerating at a constant rate of negative 9.8 meter per second square. Here is a summary of equations describing vertical and horizontal motions of a projectile. This is the end of the presentation. Thank you.